So this week we're on to testability, which is an extension of hypotheses and research questions. In particular, now we're going to have frameworks, theories, and hypotheses. And this is going to be a slightly different way to sort of conceptualize how we test things, but I think it will be helpful. Hypothesis, obviously, as a mini review, is a testable prediction. And so we had null hypotheses where we have no expectations, and then we had regular or real hypotheses in which we have a prediction, sometimes of a relationship and sometimes of no relationship. So theories and frameworks are bigger than hypotheses. So a hypothesis is not the same as a theory. Okay, hypothesis is a testable prediction. Theory is something that makes testable predictions. Okay. Now, a hypothesis and a theory, neither of those are a framework. And occasionally you see the word model thrown around. For our purposes, model and framework are the same thing, but I'm going to use the word framework. A framework is a compilation of constructs, assumptions, and theories. That is to say, it's bigger than all of these things. Okay? So understanding frameworks is really two ways to conceptualize it. One's they're sort of both kind of in what I just said, but you can think of it, it's something that contains several theories. If that helps you think of it in those simple terms, it will get you there 90% of the time. A little more specifically, it's a set of assumptions, and that includes constructs, but assumptions that several theories share. It is an umbrella, and if you're going to use one of these, two is a little more specific and a little bit more reflective of reality. So the idea of an assumption is something that we believed to be true. And I don't mean assumption like, oh, I have no idea, but like, we've tested it or it's sort of fundamental to our understanding of something. And so it becomes an assumption. An assumption doesn't have to be something with no evidence. It really should have evidence. But at some point, in order to move forward and make predictions, you have to go, well, I'm going to assume this thing I think is true, and then move from there. Let's talk about an example framework, thermodynamics, which comes from physics. It's a framework that's built on certain assumptions and certain constructs. So for example, in thermodynamics, there exists such a thing as a system, right? Some contained, it can be a thing, it can be a space, whatever, that has a state, right? And there's stuff around that system that typically affects it, usually changing that state. States unto themselves are constructs, right? Their existence is an assumption. Such a thing as energy and energy potentials, the ability, so energy contained in that system or energy in the surroundings, flow of energy, and equilibrium. These are constructs, and things about how they work are assumptions that pertain to the large umbrella of thermodynamics. And within thermodynamics, there are many theories, such as classical thermodynamics, which is interested in, the laws of thermodynamics. Statistical dynamics, which is looking for dynamics in terms of statistics. Chemical dynamics, equilibrium dynamics, under which sometimes you talk about non-equilibrium dynamics as well. So the framework is thermodynamics. It has certain things that everything under that umbrella share, or at least are willing to accept exist, and then within there are theories that make specific hypotheses. And by extension, classical thermodynamics would make hypotheses that may or may not be shared by chemical dynamics, right? Sometimes they'll share them, sometimes they won't, but they're both under the umbrella of thermodynamics. So let's practice a little bit together. So for each of the following, I'm going to talk about them more in detail, but here's the list. I want you to propose whether it's a hypothesis, a theory, or a framework, okay? The first, which I'm summarizing here, but we'll see in more detail in a second, is falling in love on purpose. Because there was an article that came out, I saw it about 5 years ago, in which you asked increasingly more personal questions and followed by looking into each other's eyes for 2 minutes, and they could cause you to fall in love. And we'll look at this again in a second. And then climate change, hypothesis, theory, or framework. So falling in love on purpose. There was an article that came out in 2015. Again, that's when I saw it, but they claimed that some of the research it was based on was 20 years older than that. This article claimed you could fall in love with another person on purpose if you follow a set of steps. Specifically, if you read the article, it's linked in this topic, so it's just a journalistic article. But in that article, the person said, I explained the study to my university acquaintance, somebody this person had known back in the day, right? Heterosexual man and woman enter the lab through separate doors. They sit face to face and answer a series of increasingly personal questions. They then stare silently into each other's eyes for 4 minutes. Oh, apparently it's 4 minutes. And the most tantalizing detail, 6 months later, the two participants were married. They invited the entire lab to the ceremony. Now, this sounds a little apocryphal to me, but who knows? Okay. And mind you, it looks like they don't make predictions regarding, people who aren't specifically heterosexual men and women. So, it makes predictions, right? Or at least maybe there's a null hypothesis in here somewhere. So according to this, is it a hypothesis, a theory, or a framework? And again, here, this is the quote I just read to you. So think about it for a second. So this actually is a theory because it generates a set of predictions. It doesn't have things under it that share assumptions. It is unto itself a theory. It directly makes predictions. So for example, if I don't ask enough questions, we won't fall in love. If we don't look into each other's eyes, we won't fall in love, etc., including this business about heterosexual men and heterosexual women, right? It makes a set of predictions. And so we could test it. It's a theory. And as we'll talk about in falsifiability, that's important, right? A theory needs to be testable. Otherwise, it is circular. Okay, climate change, my next example. Hypothesis, theory, or framework? Okay. So climate change unto itself contains separate proposals of multiple phenomena whose analyses are based on a course of assumptions, right? Each of those proposals makes testable predictions. And in fact, if you look at climate change on Wikipedia, notice that there's these different physical drivers of recent climate change. Climate change, these things are related, right? Greenhouse gases, land surface change, aerosols and clouds, natural forcings. But each of these contains they each make predictions unto themselves. So climate change is bigger than all of this stuff. In fact, climate change is a framework, right? It has certain constructs, and again, we would call them assumptions under here. They're not based on nothing. They're based on evidence people have decided pertains to all of these theories under the umbrella of climate change. But because it is larger, it contains lots of stuff, it is a framework. Okay? Now, this is not to say that I'm suggesting doubt in it. A framework is something that contains theories, and theories can be tested, which means I could falsify a particular theory and then have to adjust it under the framework. You don't falsify a whole framework. That's just not how frameworks work, right? It's once you work with these particular assumptions, you can test things underneath it. So me saying it's a framework is not saying that there's doubt necessarily, and I'm not saying you have to believe in it because I have no idea who has faith in climate change and who does not. But the idea is that in order to talk about climate change, you have to take a couple assumptions, usually based on evidence, and think about a couple constructs, and then go inside and test it. Okay. If someone wanted to try to falsify a framework, what you would have to falsify all of the theories underneath it, to the point where the core assumptions don't make sense anymore. I find that highly unlikely, but that's what would have to happen, okay? All right, so a final word to the wise in this section is the following. Sometimes theories have the word hypothesis in them, okay? The names are misleading. You cannot go off the name. So, for example, the fundamental difference hypothesis. This makes testable predictions, right? So the fundamental difference hypothesis is the idea that by not having access to UG in second language acquisition, but first language acquisition only, that this causes the outcomes. This causes people to learn or not learn. And for example, to also be affected by external factors. So it is testable, right? If I found that children, for example, were significantly helped or changed their outcome based on instruction, that would be a prediction. So that hypothesis, if I found that they were affected by instruction, would go against the fundamental difference hypothesis. It is a prediction made by the theory, that is to say, it's called a hypothesis. It's a prediction made by that could be falsified or it could be confirmed. Okay. On the flip side, if I found that L2 learners, or at least some subset of them, were not affected really by instruction, not really, that also is a testable prediction, right? And so it would kind of go against the fundamental difference hypothesis. A theory needs to make predictions, and fundamental difference hypothesis does. Ergo, it is in fact a theory. It is not a hypothesis, right? It's not like I can just put down the whole FDH and be like, okay, let's falsify this as one test. I can't do one experiment and falsify the whole thing. It's not. You could test a prediction, okay? And again, what that means for the theory, if you falsify one of its predictions, we'll talk about in falsifiability, okay? All right, so as always, if you have questions, let me know.